All right, so death packet video questions 21 through 30. Which of the following statements about the correlation R is incorrect? And this is problem number 21. The correlation and the slope of the regression line always have the same sign. Yes, I know we don't like the word always, but this is a true statement. And there we're looking for incorrect. So this is not what we want. This is a true statement. A correlation of negative 0.32 and a correlation of 0.32 have the same degree of clustering around the regression line. And that is true. They do have the same degrees, just one has this has a negative slope and this has a positive slope. So that's also true. And that's not what we're looking for. We're looking for false. Correlation measures the strength and direction of a linear association. Yep, that's what it measures. That's true. A correlation of 0.78 indicates a relationship that is 3 times as linear as one for which the correlation is 0.26. I know you're going, hey, you're going 0.78 divided by 0.26. Like, that's 3, that's a relationship. And the answer is no. And here's why. What if I have a correlation of 0? How does that apply to the 0.78? So this is false. And then, of course, outliers can greatly affect the value of R. And that's true. Outliers can greatly impact the value of R. So in other words, values that are too far in the X direction can greatly impact it. So once again, here, it's not a linear relationship. It just tells you how close data is to the line. If every man married, this is number 22, if every man married a woman who was exactly 3 years younger than he, what would be the correlation? Well, there'd be no cougars. What would be the correlation between the ages of married men and women? All right, so you could actually make your own data set and test this out in the calculator. You say there, you know what if the man was 25? Well, the woman would be 22. And 28, well, then the woman would be 25. So this is male, this is female. And you could go through the list and just make a long list of it, plug it in the calculator and see what would happen. Well, as it turns out, since it's exactly 3 years, we have an exact prediction. Essentially, we have the woman, the female, equals the male age minus 3. Whatever the male age is, the female is minus 3. Well, if every single point lies on the line, then we have 1. So if the man is 25, 25 minus 3 is 22. If the man was 28, 28 minus 3 is 25, et cetera, et cetera, et cetera. So this would be a perfect linear relationship. And since it would be a perfect linear relationship, the correlation would be 1. We'd have perfect prediction. We could predict the woman's age perfectly based on the man's age if everyone had an exact difference of 3 years. All right, number 23. Which of the following statements about residuals is incorrect? First off, I'm going to start with B. The sum of the residuals is always 0, okay? This is a true statement. This is something you need to memorize. This right here, memorize. Get that stuck in your brain. The sum of the residuals is always 0. Well, if the sum of the residuals is 0, that means if I sum them all up and it's 0 and I divide by my sample size, my average is also going to be 0. So consequently, if the sum is 0, then the mean has to be 0. In other words, if I sum all your grades up and your grade sum to a 0, your average is a 0, and we're all very sad. The regression line for residual plot is a horizontal line. Yes, all right, the regression line for residual plot is a horizontal line because, remember, it's centered at 0, and we have the horizontal line and data points sprinkled above and below, and this is for a linear regression, and they told us it was a line. The standard deviations of the residuals give a measure of how the point in the scatter plot are spread around the regression line. This was in our recipe or in our definitions was S. This is the S, the standard deviation of the residuals, and it's how far the data might be spread for a given X value above or below the line. So it's just telling you how spread out it is across our regression line, or how far individual data points will be from what we predicted. So this is also a true statement. And it says the residual equals the predicted Y minus the observed Y. Remember, residuals equal observed minus expected. Expected is the Y hat. This is the Y. So they swapped the order. We should have been going Y minus Y hat, observed minus expected, and they did it the opposite direction, and that is why this is incorrect. And they're trying to catch you by swapping the order on that one. All right, just a second. All right, number 24. Data are obtained from a random sample of adult women with regard to their ages and their monthly expenditures on health products. The resulting regression equation is expenditures, my dependent variable, equals 43 plus 0.23 times their age, with R equaling 0.27. All right. What percent of the variation can be explained by looking at ages? So when they say that, that is the definition of the coefficient of determination. So we're looking for the coefficient of determination, and that equals R squared. Well, they give me R. So I just need to go 0.27 and square it. And basically, they're wanting me to recognize that they gave me the definition of R, so 0.27 squared, and I get 0.0729. So, well, excuse me, I should say R squared equals 0.0729. So I could change that to a percent, and as a percent, that would be 7.29%. So 7.29% of the variation in expenditures for health products can be explained by a woman's age. The rest is explained by something else. So in other words, pretty small percentage explained by a woman's age. Probably another misogynistic question. On 25, consider the following three scatter plots. And by the way, please ignore the circle part right here. That's not supposed to be there. Which of the following is true statement about the correlation about the three scatter plots? None or zero. Well, no, I'm saying I don't know which way to draw a line here. That one, R should be about zero. Here, I don't know which way to draw the line to get to the most points. So that one should be about zero. On this one right here, I don't think a linear relationship's appropriate. However, the data points are pretty close to the line. And I definitely have a negative slope. So this one has an R that's going to be close to -1. All right. So two are zero and the other is close to -1. Now, please notice right here, this has a definite pattern to it. So there's probably another equation that's a better predictor than a linear equation, but this still has a very high R. So just because you have a high R value doesn't mean it's the best equation. All right. However, it still can be very predictive. So question 26, data on ages and years and prices in hundreds for 10 cars of a specific model result in a regression line. A price equals 250 minus 30 times age. Given that 64% of the variation in price, and so they tell me 64% of the variation in price is explained by changes in age or variation in age, they're telling me that R squared equals 0.64. That's what they're telling me. R squared equals 0.64. So if I were looking for R, I'm going to take the square root of that. And if I take the square root of that, and I always do that by going 0.64, I always raise it to the half power, I end up getting 0.8. So R equals 0.8. But there's one other thing I have to check out. What is the sign of my slope? And my slope is negative, so this has to be negative. And you're like, well, how come R squared is positive? Well, if I take negative 0.8 and square it, a negative times a negative, if I put in parentheses, negative 0.8 and square it, remember a negative times a negative is a positive. So R squared will always be positive, but R has to match whatever the sign of the slope is. And the sign of the slope here is negative, so R is going to be negative. So our answer choice is B, Bob. All right, on 27, which of the following is a true statement about the correlation coefficient R? A correlation of 0.3 means that 30% of the points are highly correlated. No, just know that this is a false statement, whether they say 20% or whatever, and it's not. That just tells you the overall strength. Because, like, once again, if you have it just doesn't tell you how highly it just tells you the strength of the correlation, but it does not tell you what percent of the data is highly correlated or not. Either the whole thing is or it's not. We don't worry about the individual points. The square of the correlation measures the proportion of the y variance as predicted from a knowledge of x. The square of the correlation, so r squared measures the amount of variation in y based on x. I like that a lot. So that looks like our answer, but let's go through the rest of these. Perfect correlation, that is when the points lie exactly on the line, results in r equals 0. No, that's r equals positive or -1, depending on the slope. Multiplying every y value leaves the correlation unchanged. No, multiplying every y value changes the correlation by -1. So you take the -1 times r, all right? So the sign will change. Multiplying every value by -1 will change the sign. So the correlation changes by the sign. And the unit of measure for correlation is the y unit per x unit. Wait a second, change in y over change in x, oh, that's slope. That's the measure of slope. All right, so B is our best answer for number 27. All right, number 28. A study is conducted relating AP statistics exam scores to the total number of study hours for the AP statistics class put in by students during the academic year, and the correlation is found to be 0.6. Which of the following is a true statement? On average, a 40% increase? No. Remember, if R equals 0.6, all right, that's just telling us the strength of the linear relationship, all right? And because we have that, we can basically say there is a relationship because this is a moderately strong, it's in a moderate strength. So higher exam scores tend to be associated with higher study hours. Higher exam scores tend to be associated, and by the way, it's not causative. Here they say 60% of the variation in exam scores can be accounted for this linear regression model. The answer is no, not 60%, but 0.6 squared or 36% can be done by that. All right. I have no reason to suspect that this will show up, but this would be number 29 to me as a question that I would definitely would think would be very, very fair type question to show up on an exam. So here, remember residuals equal observed minus expected. So here, if I have a negative residual, and I know it's negative because this is below the line, this is below the 0 line. So this is negatives and these are positive. So my observed must have been less than my expected. My observed must have been less than my expected. So let's draw a best fit line for these, all right? I'm gonna do this for all of them. And remember, when I do that, I'm gonna have some data points that are above the line, some data points that are below the line, except for the last one. First off, this one is every data point's on the line. So in this case, I would have no residuals. My residual would equal 0. Excuse me. My residual would equal 0. Every single data point would be on the line. So it's not that one. So I need to start off with my observed being below the line. Well, this one is below the line. Then I need to move to above the line. Then I need to move to below the line. So this is the case. Here, this one's wrong because I started off above the line. My observed is above, so it would have to be a positive. All right. And the same with this one. All right. So these two would actually have very similar residual plots. B and C, their residual plot would be very similar, and they would be turned so that they look like this. All right.